Hello everyone, welcome again to another series of video from Electronics Eternity. Uh, this video will be a continuation of my part 1 LCD video. So if you haven't looked at it, be sure to check that video out before you watch this video, as this is a continuation of my first video. Okay, so this time around we'll be focusing on colors. Okay, so as I have promised before, I will be making a specific video on how colors are derived and how I have created a function specifically for defining the colors that you want. So this is the video where I will be fulfilling those aspects. Okay, so uh, to understand how colors are derived, so as usual, I'm gonna start with a bit of theory first. Right, so when I say theory, I'm always gonna go back to my data sheet. Right, so this is the data sheet of the colors. Okay, so when you have set your color orientation to RGB mode, right? uh, I think there's a command that you can use to set your color orientation to RGB or BGR. So I think we discussed this on our first video, and that command will be 36, right? So this is one of the configuration that you need to look into, right? So if your color orientations are RGB, then you need to have that as your understanding before you derive colors, right? Because if your setting is RGB but then your entire code is written based on BGR orientation, then the whole thing is not going to work. You be scratching your head figuring out where you went wrong and why the color that you want is not appearing. Okay, so before you start, just make sure that you have the right values that you have set accordingly, and then we'll go to derive how the colors are built on. Okay, so as you can see, when you are using, this is datasheet page 55, just in case if you want to refer back. So this is 16-bit pixels. So the first 5 bits are going to be red color pixels, right? Not red color pixels. It's just the first 5 bits are going to represent color red. Okay, so and if we go to the next one, and the subsequent 6 bits, which is bit number 6 to 12, if I'm not wrong. Sorry, no, 6 to 11. Okay, so bit 6 to 11 is going to be the bits that represents the green color. Okay, and finally for the remaining 5 bits will have blue color. So these 5 bits, the last bits, will represent blue color. Okay, so so in total we have 16 bits, and based on what values we put in these bits, then the color will be populated. So for the ease of understanding, let's look at this picture over here. So the first 5 bits is red, and the subsequent 6 bit is green, and then blue, right? So in order to produce the darkest, or to say the brightest of blue, you're gonna have to create 1 1 1 1, and the lightest of blue, of course, is going to be all zeros, right? So the same goes for green, right? The darkest or the brightest of green is going to be all 1, and then the lightest is going to be all 0, and the same applies for red as well. So based on this color combinations, then your final color will be derived. Okay, so for example, I think if you add red to green, then you will probably get you'll probably get yellow, if I'm not wrong, right? So and if you have all colors to the brightest setting, you will have white. If you want to create blue, just set all the other colors to 0, and then this will be all 1, then you'll get the blue, right? So all colors are in some way derived from RGB, red, green and blue, right? So green plus blue, I think it might give you some color called magenta or cayenne. Excuse me if I'm pronouncing the color wrong, right? But I hope you get the idea. Okay, So that is how the colors are constructed. Okay, uh, as simple as that, right? It's all 0 1 0 1s, and these bits, as per their sequence and arrangement, will represent if it's either red, green, or blue. Okay, so now let's go back to this, right? So we have 16 bits here, but then how did we end up with this hex codes? It's simple. It's just direct conversion, right? So let me prove it to you by, as usual, by using our bin to hex converter. So we have over here, let's just take the first color, black. No, black is going, it's all zero, so it's going to be very easy to identify. Let's take something like blue. Okay, so when you have blue, 0 0 1 F, so let's take blue and let's upload that. So let's see what do we get. So done uploading. So when 1F is converted to binary, it's all the first 5 bits are going to be all 1. So let's go back to the diagram. First 5 bits is all 1 and the remaining is 0. So that tells us how do we get blue, right? So we set all 1 1 1 and the rest is all 0. You can even set 1 1 1 0 0 or 1 0 1 0. It doesn't matter, right? It's all about in increasing tone of blue colors, right? So the highest or the brightest of blue would be all 1 at the first 5 bits, as simple as that. Okay, just to further prove this, let's take more colors, right? Let's take red, right? So we have F800. So we have F800 and the respective binary bits would be, so this is 1 2 3 4 5 6, hold on, I'm losing count, 3 5 7 9 11 and the remaining 5. So this is red, so it's the first 5 bits, right? First 5 bits is 1 1 1 1 1 and then the remaining is 0. That simple. Okay, so let's take another red which is probably a little bit lighter or darker, we'll know. So upload that and let's see where the code goes to. So you have 1, so simply a 1 over here and the remaining is 0. So if you look at the diagram, it's 1 over here and the remaining is 0, and because the remaining of green and blue is 0, there's no values, it becomes a red, probably a lighter version of red. So let's take one last color, probably something that will be a combination of other colors. Let's take yellow, right? We have yellow over here, so we have FFE0. So let's upload that, and so this is how the bit will be. So if you can see, the last 5 bits, which is the blue color, the bits for blue color is untouched. However, the remaining is set to all 1. So it's simply because we want to produce yellow color, right? So yellow color is a combination of red and green, and therefore you will get yellow. Okay, so I hope by doing this and by seeing the respective binary values for this hex codes gives you a picture on how colors are derived in this, right? So this is the conventional way of doing this. Even in many libraries they do this, but however, I'm not really satisfied with this, right? Because you can't be remembering all the hex code, right? So even in blue you might have a dark blue or a light blue or something, that basically a different tone of blue. So it happens for all colors, right? And it's just probably for someone who wants a lot more color variation. So if they settle for this, it's going to give only one tone of color, right? So and also remembering all this and changing and every single time you want a new color to be able to identify those and define those, it's a bit tedious, right? So what I have done here is I have created a new void just to to easily come up with colors that I want. Okay, so let's look at this, the content of this void. Okay, so we have this function over here, so which will convert the percentage of how much red color or green color or blue color that we want into bits, right? So red and blue will be multiplied by 31 after divided by 100, simply because there are only 5 bits, and the highest of 5-bit value when all is being set to 1 is 31, and then therefore we're just simply multiplying by 31. And since green is 6 bits information, we are multiplying that with 63. Okay, so let's just say for red I select 70%, so 70% divided by 100 will be multiplied by 31, will probably give us something like 7 over 10, 7 times 31 divided by, so somewhere around 21% or 22%. Sorry, my bad, it's not 21%, it's actually 70%, right? So 70 divided by 100 times 31, so it will give us 22, right? So 22 in comparison to 31 as the highest value. Okay, so the same will be done for the rest of color, and then we're gonna just round it off, because when we are doing division, there's a high chance that we will get decimal places, and therefore we are just rounding this off. So what happens next is, once rounded off, it will become round numbers, and then we will transfer the bits accordingly. So red will be transferred 11 bits to the left, and green will be transferred 5 bits to the left, and blue will stay where it is. So why we are doing that bit shift is simply because I want red to be 11 bits to the left, simply because there's 5 bits over here and there's 6 bits over here. 5 plus 6 is 11, and therefore I'm shifting it 11 bits to the left, so that the red color bits goes to where it should go. So the same with green will be shifted 5 bits to the right, so that it will end up in the middle. And blue, we don't have to do anything to it, it will stay where it is. And finally we'll have a 16-bit like this, right? So it will then return the values. Okay, so I hope you understand how this void works, and if you got more questions, you can always post it in the comments, then I can explain the maths to you. Okay, so that is all for the void that I have created. Now let's see how practical it is to use it, right? So I'm setting I'm setting a 16-bit sorry 60 a byte 2-byte data over here, which is color. Okay, so it's going to be select color, and this is the red percentage, remember this is the green percentage, and this is the blue percentage. So let's just say if I want something to be red, what I'm going to do is I'm going to set this as 100%, right? And then I'm going to upload that. Okay, so once uploaded, then you can see the red colors comes out over there. So let's just say if I want only green, so what I'm going to do is I'm going to set the middle value to green, and I'm gonna get green. So let's just say if I want blue, so what I'm gonna do is I'm gonna set blue to 100, and I'm gonna get blue. So blue is a little faded, hope you can see that. So let's see what happens if I combine colors, right? So I combine this to 100, and I get a color which is I'm not too sure what's the color. Is that magenta? So let's just say if I want something lighter, then I can always play with the numbers. I can set this to fixed 50, and let's see how the color comes out. So I get a kind of different color. So this is a lighter blue, if I'm not wrong. So let's probably increase this to 80. Let's see what happens. Yeah, it's a little different. right? So let's see if I play with this number. So I get something sort of the greenish, right? So it's always that you can play with this colors and see how it turns out. RGB. So I basically get something like a pale green. I'm not too sure if you can see it in the screen. So let's try something that will be visible. So like red and green will give us yellow. So let's try that. Red and green, yeah, it gave us yellow. So how? So probably if we were to change this to 80 and this is to 50%, let's see what the color comes. I basically got something red, like really thin red RGB. So probably I should increase this to 100. Let's see what happens. It's a different kind of green, right? It's let's compare how much different it is than this green. I hope you can see it. So you see when this both is 100 it becomes yellow, but when I change this to 80 I get something like green. So let's just say if I set this to 50, probably I'll get a darker green, right? I just hope that you can see this on your phone or on your device. So I hope you get the idea that I'm trying to convey over here, that by playing with this percentage you can just vary the colors and hopefully you'll find a color that you like. Okay, so finally, just to demonstrate that, if, in order to produce white color, what you're going to do is you're going to change all that to 100. And another good thing about this is uh, it's easy to use because you can even insert it here itself and it would still work, right? So for example, let me just upload that and I get no error and the same line. So anywhere along in your program you want to set a color, you don't have to define a new variable. You can just key in like this and it would still work. Okay, so I hope you find this tutorial useful and this void useful as well. Hopefully for someone who's really particular about colors, they can use this and maximize whatever display outcome that they need, right, to the richest extent possible, if it works on your end, of course. So with that being said, that's the end of the tutorial for today. I hope you enjoyed learning this. Thanks for watching. Don't forget to like and subscribe. Thank you. Until then.